I'm going to try to go through M13 very quickly, and I use my ID, so the questions may look slightly different, and also the ordering is different, but most of the questions are very similar. So let's get started with the gradient descent question. So the formula is always you are going in the negative direction of the learning rate multiplied by the gradient. So the key thing is figuring out what this gradient is. So we know the function c already, and first we need to figure out whether we are in the 0 part or in this 1 minus ay part. So let's figure out a and y first. We know y is 1, and we know a is just w transpose x plus b. So w is 1, x is minus 3, b is 0, so this is minus 3. So 1 minus 3 times 1 will be 4. So 4 is larger than 0, so we are in this region here. So basically now c is just 1 minus this. And now when we take the derivative, we just do the derivative with respect to a, that's a chain rule, and a with respect to w. So the first part, c with respect to a, is just minus y. Yes, and it's just minus 1 here because y is 1. And a with respect to w, if you look at this expression, it's just xi. And xi here is minus 3. So if we multiply them together, the gradient part is 3, and the learning rate is here is 2, and original w is 1. So it's 1 minus 2 times 3. That's the first part. And the second part, we use another color, is b minus lambda derivative of b. So the only difference is when a is differentiated with respect to b, you get 1 instead of this minus 3. So it's basically the same expression, except for we have b minus 2 times just the minus 1 here. So that's question 1. And let's move on to the next one. So here we are asked to find the x gradient and the y gradient, and then we want the gradient magnitude. The good news is we only need the center element, so you don't need to compute the whole matrix. Because when you compute the whole matrix, you need to flip this and then multiply by the first to get the first element, to get the second element and third element, and you need to repeat this 9 times. So don't spend time on that on the midterm with a time constraint. So you just align the center to figure out the gradient of the element that we want. So here we just want to flip the filter and just directly multiply it this way. So a faster way to do it is to just multiply stuff in reverse order. So you can do this 1 multiplied by this 3, and then 2 multiplied by this 3, and 1 multiplied by 9, and so on for the other ones. So we can directly write this thing down. So the x gradient, let's do x gradient first. That's 3, 6, and minus 9. And this is multiplying minus 5, so 5 minus 14, and minus 1 minus 10, so it's plus 10. So that part is the x gradient, and we square it, and then we add the y gradient, which is, you can do the multiplication the same way. So the last element multiplied by the first element, or if you want to flip the filter and then multiply, it's okay too. So it's 3 and plus 0 minus 5 plus this is minus 1 multiplied by 9 and 6 and 10. So we square this as well, and at the end we just take the square root of the whole thing. So that square root is for the gradient magnitude. I don't remember the notation we used, but say G is that. And you can type the expression in here. Okay, move on to the next. We have this transition matrix, and we're asking about the CDF inversion method, which is the one you used in P3, I guess, to generate random words from this transition probability. So here we start with I. So remember, the first row is I, and the second row is M, the last row is root. You should probably label them this way so that it's easier to see. And if we start with I, then the CDF, you can imagine it on a number line, and we have 0.43 here, and 3.5, and then 0.22. And we're drawing a number between 0 and 1 that falls in one of these three bins. And the first number that we draw is 0.32, so U1 is somewhere here. And if we are here, it corresponds to I, and here we get M, and here we get root. So the first one, the first word after the word I is also an I. So at the moment we have I, and then the next word, we are still starting from I. So if the first word we get is M, then we need to take out, say, the second column. But here, the second word is still I, so the CDF is the same. So we're kind of lucky here. And 0.63 is, let's see, it's somewhere in between here. So that's U2. So that's why we get M. And now we can convert them back to 0, 1, and 2. So I is a 0, and M is a 1. So that's why I have 0 and 1 here. Okay, the next one is the kernel matrix. So remember, the kernel matrix formula is KXY is phi x transpose times phi of y. So these two functions must be the same, and when we do the dot product between them, we need to get this expression here. So when we have an addition, we probably need one different element. So what we want is something transpose multiplied by something is this expression. So the first part would be this multiplied by this. So the question becomes, what function, when you multiply them together, you get 7xy. So, well, square root 7x and square root 7y. And also they need to look the same, and the only difference is one was x, the other one was y. So that's why we have square root 7, not 7, or 1 and 7 or something. And the next item is 5 times 1, so it's square root 5, square root 5. And the last one is similar, 3 to the power x, 3 to the power y. So now we get the features. The only thing is to substituting x into, say, one of these features. So that's why it's square root 7, square root 5, and square root 3 to the power 1, which is this. Okay. The next question is asking about leave one out accuracy. So the idea here is basically we have how many items? We have 58 items. Every time we're just going to take one out and then use the remaining 57 of them to train the k-nearest neighbor or any other classifier. And then we use the trained classifier to predict the one that's left out. So leave one out and then train on 57 of them. and then try to predict that one. And if we repeat this process for all 58 of the data points, we get an accuracy out of 58, then we can just compute the leave one out accuracy that way. And I mean, how many of these are classified correctly? And the thing we're training is k nearest neighbor with k is 57. So we have a training set of size 57. And the k nearest neighbor k is 57. So what it means is it always everything is the nearest neighbor. So all the training points are neighbors. So the only thing we need to do is to do majority voting. So when they vote, we always use the majority, which is positive. So what it means is this classifier is always going to predict positive. So how many of these are going to be predicted correctly? There are 32 of them that are positive, and there's a classifier that's always predicting things as positive. So the accuracy is just this. It's just a fraction of things that are predicted correctly. The next one, hardest part is translating this English into, well, not English. So let's do that. And we want to write the probability. The first sentence is translated to probability of I forget given I finished is 0.363. And the second sentence is given they did not finish, they forget. So probability of forget given not finish is 0.49. And at the end, there is a prior probability of finish. So this is probability of finish is 0.25. So now the question is asking finished given forgot. Let's write it here. Finished given forgot. So you can probably imagine that you know these other conditional probabilities, you're going to use Bayes rule. So the Bayes rule formula is just flip this and multiply it by finish divided by the same thing plus, maybe let me write it. So forget given finish plus forget given not finish. So now the question is, do I know all of this? So yes, this is just 0.63. This is 0.25. These two are the same, 0.63 multiplied by 0.25. This one is given as well. This one is just 1 minus 0.25. So we get all the numbers, you just type the expression in. Okay. So the next question may look like a trick question. It's not. It's really just adding up these two numbers. So we are training an SVM on classes 2 versus 3. So we only need the data for 2 versus 3. So we just add them up. I think the other version of this is the 1 versus all SVM. In that case, you just need all the data points. You just sum everything up. Next one. Next one is very similar to the leave one out accuracy question we did. The only difference is we're using 1 and n here. So when we use 1 nearest neighbor, if you test it on the training set, everything is going to be classified correctly, because the nearest neighbor of that example will be just that example. So everything will be classified correctly. So the accuracy will be 1. And I think the other version of this question is the 1 is replaced by something like 57 or something. So in that case, it's going to be, again, the majority classifier, which the majority is negative here. So if k, say if k is 57, then the answer is 32 divided by 25 plus 32. Okay, so here we're given a table, and the table is split on 2 pages, but the good news is we can write stuff in between. So let's first write down the formula. So h of b given a, the conditional entropy is just conditional on a is true multiplied by the probability that a is true, plus conditional on a is false multiplied by the probability that a is false. So let's start with the first part. What's the probability a is false? A is true is just counting the number of these. There are 3 of them. There are 8 items in total, so 3 over 8. And then we just want to find the regular entropy of B, so which is F, and T. So it means 1/3, 2/3. So 1/3 log to 1/3, extra bracket, 2/3 log to 2/3. So that's part 1. And part 2 is 5 over 8. And let me highlight the other ones. There are 3 F's and 2 T's, so it's the 2/5 and 3/5 ratio. So same formula. Remember, it's log base 2 and log base 2 3/5, and you just add them up. Okay. And as I think the TA mentioned in the review session, this question is not great because I randomly generated this information gain. I would like the question to be this is always 0, but it turns out it's kind of hard to generate that. So I had this, and this is very hard to compute. So the only way to do this is actually try all different combinations of these 2 numbers, and then compute the information gain, and then figure out, like, with a specific pair of numbers if it works out. So basically, that question is not great. And when this is 0, this question is very similar to another question in M13, so I will go through that one, is asking about what probability should we give so that 2 variables are independent. So by the way, if these 2 variables are independent, then the information gain would be 0. So that's why asking when 2 things are independent is the same as when asking when the information gain is exactly 0. So I will skip this and we'll move on. So the next one is you have an activation map like this, and you want to find the activation map after our 2x2 max pooling layer. So max pooling, there are no weights. We're just taking the max of each 2x2 region. And the question is non-overlapping. So we don't do this and then this and so on. So we just do 4 of these. And then we find the max in each 2x2 region. So the first one is 7 and 3 and 1 and 5. Yeah. Okay, so the next question is about the underwear and about the probability, the fraction of these people who do not wear underwear. And the question they are asking is whether you are wearing underwear. So let's say P fraction wear underwear. So suppose that's P, and then at the end we'll just do 1 minus P. Suppose the fraction is P, then first we flip a coin, then 50% of them will say yes. And next, the other 50% will say yes if they wear underwear. So basically, the fraction is 0.5 multiplied by P. And we know the result, which is the total number of yeses is 0.82. So this is basically the percentage of people who said yes. And we can solve this. So this means P is 0.82 minus 0.5 divided by 0.5. And we want the probability of these people not wearing underwear. So it's just 1 minus the expression we have. Okay, so this is the question that I was talking about earlier, about figuring out the numbers such that two variables are independent. So the definition that I had in the lectures of independence is basically A given B is the same as A. So I think that's harder to verify. So I'm going to use the more standard definition of saying probability of AB is A times B. If that holds for any combinations of A and B, then the two variables A and B are independent. So in particular here, I'm going to just do probability of A is 0, probability of B is 0, and hopefully at the end, it's going to be equal to probability of A is 0 and B is 0 at the same time. So probability of A is 0 is the sum of these two. Maybe let's use the variable P here again. So this is 14 over 4 over 14 plus P. And probability of B is 0 is just the sum of these two. Is just 4 over 14 plus 3 over 14. And probability of A and B are both 0 is just this cell, this element here, which is 4 over 14. So now given this, you can just solve for P. P is just 14 over 4 divided by, this is a half, and subtract 4 over 14. So when you get P, you can get the other one by 1 minus everything else, which is like half minus P. Yeah. Okay, so now we are on to the last question. And we have the naive Bayes. So when you see naive Bayes, you automatically know the structure of the Bayesian network. It's Y as the parent of everything. So there are x1, x2, x3, and x4. So which probabilities, which conditional probabilities do we need to estimate? Everything given the parents. So P1 given the parents, let's say Pi given the parents, and P2, and there are full of them. I is 1, 2, 3, 4, and also we need the parent. So Y does not have a parent, so just Y. So first, let's start with this. How many numbers do we need to store? There are 5 classes. If we know 4 of them, then the last one is just 1 minus the probability of being in the other 4 classes. So we need 4 numbers here. And there are 4 of these, so it's 4 multiplied by something. And given Y is 1, given Y is 2, 3, 4, and 5, they are not related, so we need all 5 of these. And suppose Y is 1, how many of the X probabilities do we need to store? There are 3 possible values for each X. So knowing the 2, you can compute the other one. So basically, if we know X, say 1 is 1, given Y is a particular Y, and x1 is 2, given y is y, we can compute the last one by saying 1 minus these 2. You can get x1 is 3, given the same y is y. And y can be any of the 5 classes. So that means for each x variable, you only need to store these 2 numbers, and the last one can be computed. So that's why we get 3 minus 1, which is 2. So that's why at the end is 5 to 4 plus 4.